Good day. We will talk about fresh water central cooler, fluid flow, filling of central cooler, and parts of central cooler. What is fresh water central cooler? Fresh water is used in a closed circuit to cool down the engine room machinery. The fresh water returning from the heat exchanger after cooling the machinery is further cooled by seawater in a seawater cooler. Central cooler consists of seawater as cooling agent and fresh water as fluid to be cooled. Parts of central cooler. Butterfly valve installed in seawater inlet and outlet as well as fresh water inlet and outlet. Pipe or piping, coated with rubber on seawater side to protect the pipe from corrosion. Ball valve, installed as vent valve and drain valve on seawater and fresh water side. Heat exchanger consists of series of plates for heat transfer. Symbol and color diagram. Valve green color means open for seawater. Blue color means open for fresh water. Gray color means close as general. Green pipe means filled with seawater. Blue pipe means filled with fresh water. Gray pipe means empty or just only air inside. Green central cooler means filled with seawater. Blue central cooler means filled with fresh water. Gray central cooler means empty or just air inside.
Filling of central cooler on seawater side. First, central cooler is filled with air and must be expelled in the system. Central cooler plates will be filled with seawater from bottom going up while expelling the air. Seawater transported from seawater pumps. Seawater inlet valve. Seawater drain valve. Central cooler seawater filter. Central cooler. Seawater outlet valve. Seawater vent valve. Seawater going to overboard.
Let's begin and fill the central cooler with seawater. First, close the drain valve. Seawater from seawater pump. Second, open the inlet valve slowly or crack open until air pass through the vent valve. The seawater will slowly fill and expel the air in the system. When seawater is flowing out from the vent valve, it means that the cooler is filled with seawater. Close the vent valve. Slowly open the inlet valve to full open and check the system for leaks. If there is no leak at the system, slowly open the outlet valve. The seawater will leave the cooler and directly send overboard. Check and record the inlet and outlet pressure as well as the inlet and outlet temperature of cooler for maintenance reference.
Now that seawater side is filled, let's fill also the fresh water side. Central cooler is filled with air and must be expelled in the system. Plates must be fully filled with fresh water and the flow will be from top going to bottom.
First, close the fresh water drain valve. The low-temperature fresh from pump will be transported to the system. Open slowly the inlet valve or cracked open until air comes out from the vent valve. The central cooler will slowly fill with fresh water and air will be expelled. When fresh water is flowing out from the vent valve, it means that the cooler is filled with fresh water. Close the vent valve. Slowly fully open the outlet valve and pressure check the system by checking for leaks. If there is no leak at the system, slowly open the outlet valve. The fresh water will then leave the cooler and will go to cool other heat exchangers and engines. Check and record the pressure as well as the temperature for reference. Now that seawater and fresh water is filled, central cooler is already in service. Here we have the overview of plates inside the cooler. Each plate is installed with rubber gasket to prevent flow of seawater to fresh water and vice versa. Left plate rubber gasket is installed for seawater. Seawater will come from bottle passing through plates and will leave on top, while right plate's gasket is installed for fresh water. Fresh water will come from top passing through the plate and will leave on bottom. Here you can see that series of plates are installed and each plate is alternately used for seawater and fresh water for efficient heat transfer.
Let's check the flow of fluid. Cooler plate. Seawater inlet at the bottom and normal seawater temperature passing though. The plate's going up and becomes warm water. Seawater will then leave the cooler at the top. Hot fresh water inlet is located at the top, passing through the cooler from hot fresh water to cooled fresh water, leaving at the bottom. This flow of fluid is called counterflow cooling. Let's look at the cooling performance diagram of counterflow cooling. Vertical line represents the temperature of fluid while horizontal line is flow and travel of fluid in the cooler. Cold seawater will enter the cooler and absorbs the heat from fresh water until it leaves the cooler as warm seawater. Fresh water cooling starts at warm seawater as it passes through the seawater cold region for optimum heat transfer. Fresh water is cooled below warm seawater temperature. The incoming cooling medium seawater absorbs the hot fluid fresh water as it travels in the opposite direction. The seawater heats up as it travels through the cooler, but as colder water enters the cooler, it absorbs more heat, reducing the temperature of fresh water to much lower than could be achieved with parallel flow.
Parallel flow cooling. Inlet of seawater and fresh water are both located at the bottom of the cooler and flowing at same upward flow, leaving at the top of the cooler. Let's look at the performance diagram of parallel flow cooling. Seawater inlet and fresh water inlet will enter the cooler at the same time. Seawater temperature will slowly start to increase while it absorbs the temperature of hot fresh water. The fresh water temperature will start to decrease as it passes through the cooler, but fresh water temperature will not decrease lower than warm seawater temperature. The fluid needs to be cooled down, flows through the heat exchanger in the same direction as the cooling medium. This will cool the hot fluid down by a considerable amount but is not efficient as the counterflow cooling system.
Here is one example. Counterflow cooling example. Fresh water inlet temperature is 51.5 degrees Celsius. Seawater inlet temperature is 32 degrees Celsius. Let's introduce the seawater into the system. Seawater temperature will slowly increase. 37 degrees, 39 degrees, 42 degrees. Fresh water temperature will slowly decrease as it travels through the cooler. 47 degrees, 43 degrees, 39 degrees. And fresh water outlet temperature of 36 degrees. And seawater outlet temperature of 45.1 degrees. Let's see the value at our central cooler. Fresh water enters the cooler at 51.5 degrees and it will leave the system at 36 degrees Celsius. While seawater enters the cooler at temperature of 32 degrees and will leave at temperature of 45.1 degrees Celsius. Fresh water outlet temperature is less than the seawater outlet temperature by counterflow fluid.
Parallel flow cooling example. Fresh water inlet temperature is 51.5 degrees Celsius while seawater inlet temperature is 32 degrees Celsius. Fresh water and seawater will flow in the same direction. Seawater temperature will increase while fresh water temperature will increase. Seawater inlet temperature is 34, fresh water temperature 50. Seawater inlet temperature is 36, fresh water temperature 48. Seawater inlet temperature is 38, fresh water temperature 46. And fresh water and seawater outlet temperature as it leaves the system is 44 and 40 degrees Celsius. Let's put the value at the central cooler. Fresh water enters the system at temperature of 51.5 degrees and it will leave the system at temperature of 44 degrees Celsius. While seawater enters the system with temperature of 32 degrees and leaves the system at 40 degrees Celsius. Fresh water temperature is higher than the seawater outlet temperature. Counterflow cooling system generates much heat transfer than parallel flow cooling system because the fresh water outlet temperature with counterflow cooling is less than the seawater temperature and the difference between inlet and outlet temperature of fresh water is greater.
To summary, air must be expelled in the circuit to achieve optimum sealing effect. Seawater is used to cool low-temperature fresh water. Fresh water is used to cool the engine and other heat exchanger. Counterflow cooling. Fluid flow in opposite direction while parallel flow cooling. Fluid flow in same direction. Counterflow cooling is most efficient cooling flow.
That's the end of the topic about central cooler. Thank you for watching.